The topic of this brief presentation is, what does the moon have to do with nuclear fusion? Well, let's get right into it. Here's a really important question for the discussion today. Are these vehicles green? The car in which the girl is fueling it, the truck, the van, and the bullet train, are they green? Well, ultimately, the answer to that depends on where the electricity comes from. Let's explore. Unfortunately, the present source of electricity production throughout the world comes from the burning of fossil fuels and nuclear fission. In fact, almost 80% of our electricity comes from this. Fossil fuels have cons with significant greenhouse gases, and nuclear fission has really bad cons. It produces radioactive waste that must be stored for 100,000 years, and there's possible catastrophic effects and storage issues, as we've seen with Chernobyl and leaks throughout the world. The future source of electricity production will come from nuclear fusion, not to be confused with nuclear fission. Fusion is when two or more atomic nuclei combine or fuse under extreme temperatures and ultimately get more energy out than was put in. That's nuclear fusion. There's two main reactor types, what we call fusion 1.0, between substances named deuterium and tritium. And then there's fusion 2.0, in which there's deuterium and helium-3. The good news is, for both fusion 1.0 and 2.0, there's no possible explosions. We won't see another Chernobyl with this. There are differences, however, between fusion 1.0 and 2.0. In fusion 1.0, you still have storage issues, but with fusion 2.0, not only is there no explosions, there's no radioactive waste. And when you use helium-3, this will become the world's first true green energy. This is right around the corner. There's contracts for early levels of electricity, such as between Helium Energy and Microsoft, that will take place as early as 2028. But the bulk of commercial fusion reactors will come online over the next 10 or 20 years. The prediction is fusion will replace nuclear fission and the burning of fossil fuels. Let's dive into this a little bit more. This slide drills down a little bit more between the difference between the fuel sources. Again, fusion 1.0, we coined that term, that uses tritium, and then fusion 2.0 uses helium-3. If you look at this table, it's really important that the plus of both of these is they cannot explode, unlike nuclear fission. However, that's where they differ. Nuclear fusion with tritium requires the storage of byproducts. But with helium-3 and fusion 2.0, there's no storage of byproducts. In fact, fusion 2.0 with helium-3 cannot explode, has no significant byproducts for containment, does not cause significant degradation to the reactor, it's markedly less dangerous for the human, and it yields more energy. When we use 2.0, use helium-3, that type of fusion reaction will truly be green. In order to convert the world's electrical needs to that being produced by nuclear fusion, you would need about 2,855 fusion reactors throughout the world. The average fusion reactor would consume about 200 kilograms of helium-3 annually, and that would be a need of about 570 metric tons of helium-3 per year to fuel nuclear fusion throughout the world. If you compare that to fossil fuel burning, you would need about 31 billion metric tons of coal to produce the same amount of electricity. Well, now that we know that nuclear fusion could be powered by helium-3, and that would be ideal, and we would need about 570 metric tons to power all electricity made by fusion throughout the world, where can we get it from? Well, on Earth in the United States, there's less than 20 kilograms of helium-3. It's a byproduct of nuclear weapons production, and that quantity is actually going down. You can't mine it, you can't produce it, and it's doubtful that it could be a byproduct of actual nuclear fusion production. However, the good news is there's an estimated 1 million tons of helium-3 on the moon. If that number is accurate, that will be enough to power nuclear fusion reactors on Earth for hundreds of years. At our company, Lunar Helium-3 Mining, our singular focus is to solely and efficiently extract lunar helium-3 and economically return it back to Earth. In order to do that, it's critically important to understand the moon's environment as much as possible. Future energy production will come from fusion. Fusion 1.0 tritium is not green energy. The byproducts must be stored. However, the good news is Fusion 2.0 with helium-3 is the world's first true green energy. There's no waste. It cannot explode. It has higher energy output. And relatively, you only need 570 metric tons to supply all the helium-3 needs per year throughout the world. The good news is there's over 1 million tons of helium-3 on the moon, and that's enough to power fusion reactors for hundreds of years. Now, lunar extraction of helium-3 will be difficult for sure, but it's essential to reduce the greenhouse gas effects and make electricity greener for the world.